Welcome to Sound Policy, a new podcast from FM. On this podcast, you'll hear from engineers, researchers, and insurance professionals who are helping shape the future of protection and progress in business. I'm Brian Amaral, your host for this episode. I spent a decade and a half as a journalist, asking questions and seeking facts. Now I work for FM, a leader in commercial property insurance, and on today's show, we'll be asking questions and seeking facts about lithium-ion batteries. They've become commonplace in our lives. You're probably listening to this podcast with at least one of them. And they're becoming even more deeply embedded in the business world, too, from data centers to robotics to renewable energy. But as many benefits as these batteries have, they have a pretty big drawback. They sometimes catch fire. When lithium-ion batteries get damaged or hot, they enter thermal runaway, a chain reaction that leads to fires or explosions. So to understand the risk, FM engineers and researchers have been studying these batteries, putting them through the paces, even setting them on fire. On today's show, we sit down with two FM experts looking into this subject, Stephanie Thomas and Ben Ditch. Welcome, Stephanie and Ben.
Hi, thanks for having us.
Yes, thank you.
Let's start out, Stephanie. Can you tell us what you do at FM, what your job is, and how long you've been here for?
I have been with FM for 11 years, and I currently am in the Chief Engineers Group within the Fire Hazards and Protection, and I basically manage a number of our loss prevention data sheets, as well as represent FM on codes and standards committees.
Ben?
This is my 23rd year. I'm in the research department, which I have been since I started back in 2003. I'm now the technical team leader of the large-scale fire team, so I'm tasked with developing large-scale fire testing. And I'd say probably over the last 5 or 10 years, I've really started to focus on emerging technologies. Automated storage is a big one, and pretty much anything you do with batteries, how you store them, what you do with them, including things like energy storage, but moving all the way into electric vehicles and all the different applications you can find.
Stephanie, you authored the data sheet on the storage and manufacturing of lithium-ion batteries. It was the first comprehensive guide to manufacturing and storing this technology. I know it's a very detailed data sheet, and there's a lot of recommendations in there, but what are some of the highlights? What are some of the main takeaways that people should have from that data sheet?
I think the main takeaway from the data sheet should really be that you cannot stop thermal runaway once the battery goes into that.
Can you explain thermal runaway and explain how it starts?
So thermal runaway is when essentially you create a short circuit within the battery cell itself, and essentially you're making that anode and cathode come into contact with each other because you're degrading the separator, and that short circuit allows those two components to come together, which then triggers a reaction which is exothermic and starts to put off heat, and that increases the temperature, and then that temperature increase can't be dissipated. It increases at a faster rate than it can dissipate that heat, and so then you have the thermal runaway reaction.
It's a kind of question that you wake up at 2 o'clock in the morning answering. What am I doing?
The protection guidance that we provide is really about managing the fire once a battery goes into thermal runaway, and then also just limiting how many different cells do get involved in that fire, and so that we can control it to a point where we limit the overall damage to the property and limit the event for our clients.
How risky are lithium-ion batteries?
There's a number that used to get quoted all the time. They said 1 in 10 million batteries fail. And I spent a day of my life trying to figure out where that number came from. It's not a number that was properly referenced anywhere. It was something that was provided in a report that somebody else then referenced. And then I went down that path of 7 or 8 references. I was never able to actually find any primary research that developed it. Even if it's true, 10 million batteries is not that many batteries. 10 million batteries is, some of these energy storage systems are getting on that number. We know they happen. There's even trackers for that. So even if they're not that common, every time one happens, a wide contingent of people in research and in code and consulting, we all get the same email saying there's been another event. So it stays very present on your mind.
I did find a statistic. According to FM research, at least 44 lithium-ion BESS fires and explosions were reported globally during a recent 5-year period that I think was until 2022. So 44 is not zero. And, when each individual loss seems like that could be a pretty significant loss. How do you do that? How do you limit that damage?
Mainly by providing copious amounts of water, which we learned through many of Ben's tests at the research campus.
Ben, talk about that testing. What does that look like?
I mean, it depends a lot on the different applications. If it's an energy storage system, then it can be up to an actual full-size energy storage system. The thing with batteries, scale matters. Understanding what a single cell looks like in a failure mode is not the same as, 10,000 cells together. And so it looks, if you're looking at a data center, it looks like a data center. If it's an energy storage room, it looks like an energy storage system. We're going to test these at full scale, and then every scale in between, all the way down to the cell. So we understand basic physics up to the full hazard, and then we get that protection solution.
And by testing, you mean setting them on fire in a lot of cases,
Setting
right?
them on fire, absolutely.
How do you do that?
Actually, not that hard. All you have to do is heat them up.
We watched a video of one of their lithium-ion battery tests.
Well, right now you're looking at the inside of our large burn lab, which is about the size of a football field with an 80-foot ceiling. So we have a large concrete test pad with a rack storage setup that's 3 tiers high. So that's 15 feet tall. We have carton lithium-ion batteries, which are in the white boxes. And then we have some target commodity. We want to fill out the test array. It gives us a better sense of fire spread laterally, but also if it would jump across an aisle space and move to another storage area. And so that's the brown boxes.
Stephanie, would this look like a typical business's configuration of batteries in one of their facilities? Does this look pretty standard?
If they're using traditional storage methods, yes.
You see a person in a firefighter gear just came in with some sort of blowtorch. What is that person doing?
Yeah, so that's our standard ignition process for a warehouse scenario. Basically, we use it's essentially a roll of gauze with a little bit of gasoline. It's just enough to get the cardboard burning. They ignite that within the rack, and then once the cardboard starts to burn, you'll start to see that vertical fire spread. You can see it here now. We've started at the first tier, and now the flames, 3-4 feet above the top of storage.
Does it look, smell, sound any different than some wood pallets? Are the characteristics of a lithium-ion battery fire any different?
Smell's a great question. It does have a distinct smell. Thermal runaway has a distinct smell when the chemicals are released. All fires themselves smell bad. Burning plastics, even from back in the 70s, were still thick black smoke. Lithium-ion batteries have a distinct nature to them. Here you have, I would say, a small amount of smoke that's been produced from a fire. It's important to note here, this is a lab. If this were an actual warehouse, that smoke would start to accumulate. So even in a test that's producing sort of this whitish smoke, it starts to get difficult to see what you're looking at. If there were more plastics involved or if protection wasn't as effective here, you'd have thick black smoke, and it's not uncommon to completely black out your lab.
Wow.
So there we have our first sprinkler operation. This is a large K-factor sprinkler, so it has that high momentum push, and you can see that. You can see it come down, and you can see it kind of push the fire plume out of its way. Now you have water cascading over the boxes. That's going to help extinguish the cardboard fire. So now you can start to see that fire is being suppressed, means it's actively reducing in size, but there's still some consistent burning, and that's in that ignition area. That's the part that's been burning the longest. It's going to be the most difficult to extinguish. It's also the part that's farthest away from the sprinklers, so there's more obstructions to getting the water down onto that ignition area. It was a success. You can see the batteries, the shiny metal on the inside there. We did have thermal runaway. We did have batteries involved, but we didn't have a propagation beyond the batteries that were immediately involved. So in this case, we were very happy with the protection, and this is a relatively minimal amount of damage.
How are building codes playing into this situation?
It's relatively hard for a building code to keep up with technology. They run on 3-year cycles. Generally speaking, that means it takes 6 years from the introduction of a new technology for it to reach code. Obsolescence on a technology could be in 3 years. So by the time you're answering the question, the industry might be on to the next version of that technology. This is not a battery problem. This is a consistent challenge as we move more and more into technology-based hazards.
It does seem, though, it's not specifically a battery problem, but maybe particularly a battery problem given how common they are. And as you were saying, data centers, battery energy storage systems, it does seem like that's going to be a huge part of these future technologies. Can you speak to that, how important they are to these new technologies that we have coming?
Sure. And it's actually not just batteries as a hazard. A lot of what I do is hazards that are enabled because of the batteries. Think of things like robotic storage. That concept of automated storage, where if you order it today and it can show up tomorrow, it's probably a robot involved. A lot of those are based on different types of battery technologies. So in some cases, your hazard is your batteries. In some cases, your hazard is enabled because you have access to those batteries. It's part of what 7112 actually does. It tries to separate those two things out. What is a battery fire and what is just a fire? Some cases, the battery is kind of like a match. It's what might cause the fire. That might not be a battery hazard. That's enabled by the batteries. Whereas something like an energy storage system, there you're predominantly batteries plus the cabling and all those. But we know how to protect cables. It's that battery component we need to understand.
I think it was there was some reference to state of charge in the data sheet. Why is the state of charge of a battery important, and how does it play a role in whether or not a battery will go into thermal runaway or not?
So at higher states of charge, it's easier to trigger thermal runaway because there's more energy there, and it's easier for that battery to go into thermal runaway, creating a more intense fire. Whereas at lower states of charge, it can be difficult to get them to go into thermal runaway. And then when they do, the fire isn't as intense for the same exact battery at, say, 100% versus 30% state of charge. And that's also one of the reasons why you see a lot of transportation regulations coming out with a threshold of 30% state of charge.
Transportation, if you're shipping these batteries, they have to be at a lower state of charge?
Yes.
As the batteries are getting bigger, is this risk getting bigger?
Yeah, this sounds a lot like our internal questions that we have within research all of the time. If you take a box of one size and you put 1,000 batteries into it, or you put 100 batteries into it with the same amount of energy, does it make any difference? And right now, that's ongoing research, but it looks like it's actually not that impactful because you only can get so much energy into that box. And so that's part of the, being agnostic in our guidance that we're trying to get down to. And right now we're actively looking to see if we have to worry about the individual size of each battery.
And as far as quantities go, part of our guidance is really to limit the overall number of batteries we get involved, and that all plays a part in the duration of these fires. Because what you'll hear on the news a lot is it took 5 days, 6 days, and that's because of, the batteries, that thermal runaway cascading to adjacent cells and continuing on. And so that can just increase the duration of the event.
Stephanie, how do you conceive of the risks of lithium-ion batteries in your own personal life? Somebody who has obviously dedicated a lot of time to understanding the risks. When you see one in the wild, when you get on a plane and they say you can't have your power bank in the hold, how do you conceive of the risks and put them in context for people?
Well, I'd definitely say I'm much more aware of the risks now, whereas before, I just carry my phone, my laptop, and I wouldn't think anything of it. Now, I take my phone, my laptop, those are kind of more, calculated risks that I'll have them charging in my house or whatever. But, the bigger batteries that go into the lawn equipment or whatever, those get charged outside now, away from the house. I don't leave them charging overnight like I would have before.
Right, wow. Ben, yeah. Do you take the same sort of practices with?
I do. I do 100%. I actually use this anecdote sometimes when I present. We as researchers, but also just in the community, know that you can damage a battery. It is really simple. If you just take a nail and puncture a lithium-ion battery, it will go into thermal runaway. It will vent flammable gases. If you drop your cell phone on the ground, aside from being very upset that the screen broke, you'll probably put it back in your pocket and walk away. So, that's the interesting part about risk. Sometimes we know better and we still do the wrong thing.
If you dropped your phone and your screen broke, would you put it back in your pocket?
I have put it back in my pocket.
I have as well. And we've had losses where basically during manufacturing, the robot malfunctioned and basically just dropped a tray of lithium-ion batteries on the floor. And there was the fire because it mechanically abused them. And so, it's a real hazard that could happen. But, we take kind of that for granted because it's an everyday device that we're all attached to.
Stephanie, for businesses that may be listening to this podcast, is there one thing that they could do if they're concerned about their exposure to lithium-ion battery fires?
The first thing they can do is really look at where their exposure is and understand the hazards. And then they can start to take a look at, if they're a manufacturer at 7112, take a look at how they can start to look at protecting their manufacturing processes, as well as limiting their storage and their state of charge where they can. And then for the storage, they can also go to 7112, datasheet 7112, to see what are the different protection options there based on how they're packaging that battery. Because, as Ben mentioned, it all comes down to what is going to be driving this fire hazard. Is it the battery, or is it all the other stuff, all the packaging and everything that the battery may be in? So that could also drive how they package their battery, right? If they're using cardboard, that's going to be a good media that's going to set off their sprinklers right away. It's going to absorb that water. But if they're going to use expanded plastic, that's going to definitely increase their fire hazard and require more robust protection. So understanding how their packaging is going to also play a role in impacting their hazard could be important when they're looking at the lithium-ion batteries in their facilities.
What about data centers, to pick that out in particular? If there's a data center business out there that has these battery backup units that are now even more integrated into the system.
So for data centers, those would actually be covered by datasheet 532. And I think each rack has to be less than or equal to 20 kilowatt hours in order to follow the guidance that's in that data sheet. Otherwise, we would consider it an energy storage system, and it would have to follow the guidance in datasheet 533.
And this is part of the challenge that we kind of touched on a little bit before. The data centers that had a small amount of batteries in each rack, that's a type of hazard. But as these power requirements get greater and greater, now we have clients that want to put more and more energy into the racks. And all of a sudden, you're transitioning an occupancy that looks the exact same, right? A data center with a bunch of server racks and a data center with a mix of server racks and battery racks fundamentally look about the same, but they don't represent the same hazard. And we have to go about the testing completely different for those.
Same question I just asked Stephanie. I think you hit on this a little bit, but what is one or two things that a business can do if they're concerned about their exposure to lithium-ion battery risks?
I'm going to answer the question a little bit sideways, just for fun here. So we've been looking a lot at loss exposure to understand what is the actual main driver of the loss. In something like data center, we use copious amounts of water. Right? That's our data sheets all say copious amounts of water. No one really wants a sprinkler to operate in a data center. Even if it does its job perfectly, the mere fact that sprinkler operated just caused a lot of physical damage. It's also a potential driver of a business interruption. So we're trying to blend active automatic protection, things that we know will protect the building, things we know will provide that level of protection we're looking for, with things like passive barriers. In this case, lower the risk but lower the frequency.
What advice do you have just for everyday people about their use of lithium-ion batteries?
Well, just like Ben and I, just be aware of the hazard and make sure, especially with your larger battery packs for your lawn equipment and things like that, you're charging them outside. And then just be aware for those smaller ones that you wear on your person, like your watch or your cell phone.
I'm going to go home and unplug my lawnmower. Thanks, Stephanie and Ben, for joining us.
Thanks for having us. This is fantastic.
Thank you.
This has been Sound Policy. Stay tuned for more interviews to help protect your purpose. I'm Brian Amaral. Talk to you next time. Copyright 2025, Factory Mutual Insurance Company, all rights reserved. This podcast is for informational purposes only and aims to highlight potential hazards or conditions to help reduce property loss. FM makes no express or implied warranties and assumes no liability for the use of any information or products mentioned.